I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Hi, it's me. Hey, I'm Cowboy Rufus. You want to see a picture of what my daddy looked like? Want to see a picture of what my granddaddy looked like? He looked like this. Oh, that's so funny. And you don't even know that this ain't no real picture frame, do you? That Cowboy Rufus, I just keep him in class so I can laugh at him. Cowboy, these are my parents. These are my parents when she was probably 18 and he was probably 23, back in the very early 50s, before I came along. I think I have another picture here. I have a picture of them at their 60th wedding anniversary. That's my mom and dad. They were both near 80 at the time. Some people tell me I look like my mother, and some people tell me I look like my father. I've met some of my students' parents, and some of you look exactly like your parents. Today, we're going to talk about parents in algebra, parent functions. This is parent functions. It's A2 IF dot A dot 2 and A2 BF dot A dot 3. Your I can statements today are, I can identify and use parent functions. I can describe the transformations of parent functions. I look like my parents. Algebra problems that have a little transformation look like their parents, the parent functions. The key matter here is our offspring look exactly like our parents. Cowboy Rufus looked a whole lot like his father. We'll humor him. Maybe he doesn't know that we know that was a poster board frame. Here are several parent functions. I'm going to describe some of these, and we'll come back to the pictures later, but this is about 10 of them. I've seen charts that have as many as 16 or 20 parent functions, but let's talk about some. Up here, of course, is where my video goes when we're done shooting this today. I've got 4 other videos that talk about parent functions. Some of them mention the functions I'm going to talk about. Some will mention other functions. There's 10 in this chart. You're going to look like your offspring. That is, an absolute value that's a little bit sideways looks the same as absolute value that's right at the vertex. Let's start with a couple of these. I have the constant function. It's a straight horizontal line. Y equals 3, y equals 0, y equals negative 17. Which one of these looks like a straight line? This one right here. Y equals 3. It goes straight across. We call it a constant function because y is set equal to a constant, not an x. After the constant function, I have the identity function. This is where y equals x. It's a line that goes up at a 45-degree angle, and it has a slope of 1. Now, let's go up now and see if we can find a function in our chart that goes right up the 45-degree angle with one solid line. There it is. It's called a constant function. It's also called a linear function because it's a line. Does it have slope? Yes, it does. It goes through 1, 1. It goes through 2, 2. It has a slope of 1, a positive slope of 1. What other functions can I talk about? I don't want to talk about all 10 of these. But there's an absolute value function. Y equals the absolute value. That's going to be a V-shaped function. Do we know anything else about the V-shaped function? It's got to be positive. Because absolute value, if it's negative, we're going to make it positive. If it's positive, we keep it positive. You shouldn't get any points down in quadrants 3 or 4. Let's go look for absolute value function. It looks like a V, and there are no negative points. It ends at 0, 0. The absolute value of 0 is 0, but the absolute value of -1 is still 1. So it's a perfect V, and that's what absolute value looks like. What else do I have down here? I have a square root function. Y equal to square root. It's a slow curve that goes up like that. It's always going to be in quadrant 1 because square roots come out positive. So we are looking for a square root function. Looks a lot like this. It goes up in a slow little curve. It's in quadrant 1. Identity function, square root function. What else have I got? I got a step function. The greatest integer is a step up or down function. Absolute value would be straight up and down lines. These curved square brackets are greatest integer function. That means you round down. 2.3 goes down to 2. 2.7 goes to 2. 2.9 goes to 2. 3.1 would go to 3. And 3, of course, would round down to 3. So this is a step up or step down function. Greatest integer function. See if you see anything up there that looks like steps. This looks a lot like steps. Looks like a staircase. So now we've gotten the constant function and the identity function, absolute value function, square root function, step function, quadratic function. And I threw this in because next chapter we're just going to talk about quadratics. Quadratic function, y equal x squared, forms a parabola. Parabola, y equals x squared. It's a parabola. This particular parabola ends its vertex down at 0, 0, and it goes up. It has no maximum because it goes up forever, but does have a minimum? Yes, it does. It doesn't go anywhere below 0. So it has a minimum, and it goes on and on forever, so it has no maximum. So we got the quadratic function. I got a cubic function, which is y equal x cubed. It's an S curve up, and it actually touches the y-axis 3 times, right? A perfect one would touch, look, we go up here, we touch the x-axis, we go a little bit down, we touch the x-axis, come back up. It's going to touch the x-axis right there. It's a curve that goes this way and then turns that way. And we have several others. We have a rational function, which is y equals 1 over x. It curves up in quadrant 1, and it curves down in quadrant 3. It gets closer and closer to the line, but it never actually gets to 0 in either shape. We have an exponential function. It's a fast curve up. Let's see if I can find those. Here's our exponential function. Starts out real low and goes up real high real quick. And here's our rational function. Y equal 1 over x is graphed like this. We have several others. We have a log function listed here. Since we haven't gotten to logarithms yet, I'm not going to talk about the log function. Let me talk about moving a parent function. If I move you away from your parents? Do you still look like your parents? Yeah, moving you down the street has nothing to do with that. From geometry, we learned that there are transformations. We have slides. That is, we can actually slide like a kiddie slide. We can bring that down. We got rotations. That's where we take an object like a triangle and we turn it round and round. We have reflections. That's where you get a mirror image. The line goes like this, and then it reflects off and it looks like this, and you get a mirror image. And we have dilations. That's where you change the shape, not the shape, but you change the size. Where you make it bigger, you make it smaller. Knowing the parent function and the added transformation makes it easy to graph these functions. I'm going to study a couple transformations. I'm going to study a couple transformations, and the easiest way to do this is with a graphing calculator. And I could use the TI-83 that we have in class, but then the screen is about yay big, and most of you can't see it. So I'm going to go here when I get to my transformations. We're going to take the identity function, y equal x, and I'm going to find out what happens if I add 4 to the x. Those are my two functions, y equal x and y equal x plus 4. So let's go there. Y equal x. This is the easiest graphing calculator around. Y equal x, I just put it in, and there's my red line. I hit plus sign for another expression, another function, and I get y equals x plus 4. That's the blue line. Does the parent function and the child function look alike? It's the same line. All we did was move it out 4 spaces to the left. What do you think would happen if I made this a minus sign? If I made this a minus sign, what do you think would happen? We now moved our line 4 spaces toward the right. X, y equal x, and y equal x minus 4 are very much related. This one goes through 0, 0, 0. This one goes through negative 4. You've seen this before. It's called slope intercept form. Y equals x. The slope is in front of x. Slope of both these lines is 1. And the intercept is 0, comma, minus 4. It goes through right here. A minute ago, we had one that went through right there. Now let's try another function. Let's try an absolute value function. We know already it's a v. And we're going to see what happens when we alter it a little. I'm going to add 2. So let's start with the first one. Y is equal to the absolute value of x. Now let's do that again. Y equals the absolute value of x. Give me plenty of space. Now, right now, both functions are the same, so all you're seeing is 1. What happens if I add 2 in here? If I add 2 in here, am I going to change the domain or am I going to change the range? We put the 2 in there. What did I do? I took my v, the first one's in red. I took my parent function v that ended at 0, 0, and I moved it 2 spaces that way. All right? What happens if I put the 2 on the outside? Am I going to change the domain or the range? That is, am I going to make it go right, left, or am I going to make it go taller or shorter? So let's put the plus 2 out here. See what I did? It's the same v function. It just moved 2 higher. Now I've got the absolute value, but I got it 2 up. It goes from here to here. Let's try one more example of a transformation. I take the quadratic function. The quadratic I've chosen because next chapter is all about quadratics. It's all about parabolas. Y equal x, and I'm going to add 3 to it, both inside and outside again. So my equation, I got to get rid of the absolute value. Y equals x. You hit the little roof on the 6, and it'll let you go up, and then you hit the 2. Now let's get rid of this function because I don't need it anymore. I will go y equals x, up function 2. Are they the same? Now I'm going to add my 2 to it. Plus, or we'll add 3 to it this time. Plus 3. What did I do? It's the same parabola. I just moved it up 3. It didn't change, except for the minimum change. The minimum here is 0. The minimum here is it doesn't go below 3. What happens if I put that 3 in the parentheses with the x? If I do this and this, have I changed anything? Not yet. But let's put that exponent on the outside. We're squaring the whole parenthesis. What did I do now? I took my parabola that was in red here, and I moved it over here. I moved it to -3. Why is it -3? Because when x plus 3 is set equal to 0, we subtract 3 from both sides. X plus 3 in parentheses is the same thing as x equal -3. So as that sign changes, if you set this parentheses equal to 0, x becomes -3. If I do this, I should get it in a slide. Here, I've moved it over and up. It's a slide. I slid the vertex from here up to here. It's a slide. It's a transformation. But the parent and the child function still look like each other. Just like crazy Rufus still looks like his grandfather. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.